So before we get started, right? I'd like to know, was it hard to get in?
Yeah, a little bit, but not that hard.
No, okay, all right. I guess we're all here now. That's my alarm going off. So welcome, God's Chibeze, Victory Naji, and Marvelous.
Thank you.
You're welcome.
Thank you.
So we'll just get right on it, or should we just wait a little bit for people to comment?
Let's give them a little time. Let's give them time.
All right. So for most of us, I'm assuming that this is probably the first time you're maybe in detail hearing what this is all about and how to implement, right? But then for some of us, we're already trying out. I'm already seeing, well, it's always Victory who's always, pushing and doing his best, and Marvelous as well. Yeah, I always see them. Keep it up.
Thank you.
It's not easy. So as we welcome everybody, because of the time limitation, the time constraint, we'll hit it up real quick, and hopefully, if there's need for us to continue, maybe after the 1 hour peak, then we can, create a new link and join in as well. All right. So, my name is Ugochukwu Akbudo. I'm Nigerian, but I'm a HDR candidate in Griffith University, Australia. My research focus is on computer vision, in particular, explainability and interpretability of AI models. So, without much time waste, let's get down to it. So, okay. Let me share my screen for us to have it. A window. What is going on? This thing don't come again, but then we'll figure it out. Okay, so let me admit someone. I tried this before, it went through. Okay. A window. Why is this doing this? Okay, someone's here. Entire screen. Is that how it works? So I'm gonna share. Okay, let me open this here, and then so I can share this. It's easier. Okay. Okay. So I'm assuming you all can see the screen, right?
You can see it.
Okay, let me make it bigger.
Yes, yes, yes.
Yeah. Okay. So we're admitting more people. More people just want to join in. And okay, if you're just joining us, we're just starting. We've been waiting for you. You're welcome. So, uh, um, this is a 2-day program, GRASROOTS-AI, a community-based initiative for educating and sensitizing and promoting the use of AI and inclusive AI acceptance in Africa. So, why should we be doing this? We already know, but just to have a run through of what we're doing. This is an initiative that was born from the several interactions I've been having with you guys and many other people. How do I start? What's the future? And this and that, scholarships. How do I join the moving train? And of course, me myself being an advocate for AI and AI inclusion, data governance, data analysis, and all things. I thought it good to initiate something that is at zero cost, but with maximum shared value. And that's what brought up the idea of invasion of AI. But before I proceed, I would like to recognize the assistance of the few people who made sure that this came to fruition. As a Niger Victory, God's Will Chibese, and Chimobi Kalo, Ikuka Chibike, Chikezie Chinwezu, Odomoris, and the other organizers on the list. So, without much time waste, Africa it reserves some of the world's oldest cultures and traditions, and the traces of colonialism still lurking in her socio-political affairs, her participation in contributing significantly to achieving sustainable development goals. The widespread adoption of AI seems hindered by her existing conservative traditional policies at the expense of AI acceptance. What exactly is this and why? We're limited, obviously. Whoever tells you we're on top or whatever, or we're leading in the conversation around AI technology is probably lying. And we all can see that. Even our academic institutions very much do not inculcate the recent technologies in their curriculum. And that's unfortunate. To move further, just because this is already being recorded, so I'm going to limit how much I interpret this. What are the key areas that we can explore AI? In education, in health, security, development, innovation, and research. And for most of us, our major concerns might be tilted towards education, health, and research. Research for those who are, trying to get their PhDs and all those things. Education in the sense that some schools are gradually, actually, just last week I was interviewed by a Nigerian university to teach. They are trying to put in a course in the university and then ask me if I can be a remote teacher for them, a lecturer. So I'm still on that. So pushing forward, AI has its limitations, no doubt, right? But one of the major limitations are it is new. Most of how it's built is still based on expensive assumptions. I call them magic. math magic. AI is the real math magic. And I know say like you know how somebody will write 2 plus 2 and somehow arrive at 30 and we call it math magic. That is what AI does. But we will run through them and hopefully get to have an understanding of what exactly it means. So, for some of us, we might have seen this already. I keep getting questions on how do I implement AI? Where do I do it? How do I start? But I think it's more important to understand why you should start, if you should start. So the number one concern is, of course, you can see how the human brain or the human development seemingly evolved from the purely animalistic to purely technology based thoughts. But the beautiful thing is, as our acceptance of technologies grows, that's the more our accuracy in understanding and modeling and predicting becomes higher. Therefore, the error keeps going down. But why is that? Over the century, there's been 3 major industrial revolutions, right? And we can see here in the 19th century, machines can one day be as intelligent as humans. It was a hope. And then the first revolution was, let's now build an intelligent machine. That's where the concept of dynamic control came into play. And then in the 1990s, there was the second revolution, right? What is intelligence? And that also brought up the idea. Sorry, that was the third. And that also brought up the idea of the AI models, intelligent models. And that was mostly because of the increased computing power. We can now run expensive algorithms in our laptops, high-end PCs. And that also brought up the idea of going deeper. Okay, applications of AI. Somebody asked me this question. So this is a full list of where you can apply AI. So for some of us who are looking for scholarships, looking for jobs, looking for remote jobs, remote blah 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 admissions, this is in particular the area where you can channel your application. Because I keep hearing people say, "Oh, I don't know how to get scholarships." It's funny because with this, if you understand how to integrate AI into fundamental ideas, let's say somebody who studied mass communication, for instance, you don't know how to integrate that into AI. That means you're not thinking. There's Chat GPT or something, that's new AI based software that gives you suggestions and all that. You can integrate that into your field of study. That is someone whose communication based, his research was that, and then he put in AI to make communication and education better. So in my field of research now, I'm doing it in agriculture. When I was in Korea, I did that for robotics and automobile, as well as healthcare, right? And healthcare doesn't really mean how to treat people. I did that for optimizing the production of pharmaceutical products. You see, so there are different areas of implementing AI, such that if you're looking for a scholarship offer or you're looking for admission, these are things you can list as I am interested in this and I want to explore the possibility of developing models in that area. Who knows? You get your scholarship. So, but that's a topic for another day. So, here is the overall view of what AI means. The concept of AI is to develop mathematical models. Remember, the key word is mathematical. Mathematical models that can mimic the human brain. That's the goal. To build artificial neural networks that can mimic the behavior of the human brain, to mimic intelligence. That's all. Okay. So, we've already gone through that. If someone has any questions so far, I'll be willing to hear them because I broke it down into sections so we don't get lost. Is there any question so far? Please unmute yourself.
Yeah.
Okay.
Um, a question would be, even though you have not yet spoken about it, but I would like to know how AI can be used in business,
In business.
healthcare business, not just healthcare, but
Okay. Okay.
healthcare business.
All right. Uh let's pull up that slide. Here, right? Let's pull up on it. So how can we use AI for healthcare business? So in healthcare now, right? Although most of the research is in CT scan, how to check the health and all those things, monitor maybe the heart or the brain using CT scans, images. A different area of it is in the money making, right? Let's say you're a healthcare businessman in the area of you produce medication, or you're a consultant, or you manage a website or a system for booking people for appointments, or helping them find the nearest hospital or the best hospital to treat them or to consult. Let's say you're a middleman, you're a businessman connecting people to hospitals. With AI, you can be able to gather data. Okay, how many people every year or every month come to this hospital and go to that hospital? How much do they spend there? How much do they spend here? What is the quality of service here and quality of service there? Okay, another thing is, how many doctors are always present here? How many doctors are present there? How many deaths happen here, happen there? When you're able to collect as many data as possible from different hospitals, I'm just creating a scenario. You collect those data and collect the patient data. Okay, what is the age range of people who are most likely going to the hospital? Is it during rainy season? How many people during rainy season? How many people during dry season? These are lots of data that can be collected over time. You can build a model that can suggest to someone. They input their name, put in their age, put in their concern. It can recommend a hospital that will best suit them. I'm just creating a simple scenario. In other areas, it could also mean for you as somebody who is a medical businessman. And the area of business I see that comes to mind now is in drugs, right? In the idea of drugs, how do you uh, optimize your business so that you stay profitable? One is by receiving feedback by the people who buy from you. Oh, this drug didn't really give me this, didn't really do this to me. It can help in your drug production process. It can also help in your business management process. It's a whole like it is vast such that it's most websites now use AI. That is the chat box. You can have that. It can respond to your customers, but at the back end as well, you can optimize your processes for drug manufacturing, for process monitoring. These are different areas. So it's vast. So once again, is there someone else who has a question? Somebody raised the hand before. Feel free. Okay, that's
It's
marvelous.
me, Marvelous.
Yeah.
Yeah. Yeah. Before, I don't know his name. Before he asked a question, you were about going into the history and the rest of it. I
Yeah.
wanted to see about that.
Okay.
Yeah. So that's what I want to tell you. I want to see that history about.
AI.
Yeah.
Okay.
Is that where we are going before he asked the question?
Yes.
Okay. Yeah.
So,
Yeah. No. Okay.
AI, it's a whole umbrella. I'll still show us that, but the focus is on deep learning. We'll still get there. The key moments in deep learning. So that was 1958, 1969, and 1986. Now, these are the key moments in the history whereby the conception of building an artificial simulation of the human brain took birth in 1958 by Cornell. That is, what's his name? Frank, right? Although at its baby step, if you Google this more, you'll see that there was a huge computer, like series of CPUs and blah blah blah, that aided that computation at that level. But over time, with the way processors are built, smaller and smaller and smaller as chips, you can have a supercomputer as a laptop, just like I have right now, right? So, here, this is a more representation of the history, right? So, the inception of machine learning and deep learning as major accepted technologies started around 2010, 2011 onwards. As of 2016, most traditional machine learning algorithms are becoming obsolete. And what do I mean by that? This is a whole umbrella of how it looks. AI involves the whole machine learning and deep learning. But in machine learning, you still have deep learning as an extract of it. So deep learning is the advanced machine learning, and machine learning is the advanced AI. However, AI involves the whole umbrella, if that makes sense. You would always see this, maybe on Google and blah, blah, blah. You would always see this. Now, AI, any machine that is able to replicate human cognitive skills, it's possible to build a model that is not AI based. That is not machine learning based, but it can also mimic human intelligence. If that makes sense. You can have a model that does what humans do, but it is not machine learning based. It can be traditional dynamic modeling. There's the Lyapunov control, intelligent control algorithms that can mimic some to some level human behavior. And machine learning, these are algorithms and statistical models for performing specific tasks without using explicit instructions. This is the advanced AI. Like, this is where AI became more serious. Statistical models. We'll talk about this soon. Deep learning is machine learning algorithms that use multiple layers. So, if you stack up multiple machine learning algorithms, you have a deep learning algorithm. If that makes sense. If you're able to build multiple layers, multiple networks of machine learning algorithms to form one full framework, that framework is a deep learning algorithm. And I'll show us. There's always a confusion between machine learning and deep learning. And how I explain it in the easiest term is machine learning statistical models. They are the fundamental structure of random modeling, in the sense that you start by initializing randomly, and then you have an intelligent model that learns over iterations, over time. Basic. But deep learning is when you have machine learning models stacked up together to build a more efficient model. Okay, people are joining in. So, in the heat of that, this is where everybody will now enter their own shop. Because whatever we're doing, I can't tell you the area of AI you should go to. And nobody should tell me that either. And that is why it's so open and it has potentials such that any area you want to go into, you will still get it. So, but in broad, how can we practice this AI? How can we train models? If you keep hearing what I say, you train this model, you model, it learns. So how do you learn? Right? What we know in general as adults is supervised learning. And I'll explain. Overall, we have three major types of learning: supervised, unsupervised, and semi-supervised learning. In fact, we have another one, reinforcement learning. That is a different conversation. But for us as adults, nobody at this stage will teach you something without you at least trying to verify it. If that makes sense. So, what you learn, you try to check if it makes sense based on established facts. If that makes sense. So you're supervising your learning process. As I'm learning this thing, is it correct? Unsupervised is there is nothing to check the validity of that. And that same concept, remember, AI is also mimicking the behavior of the human mind, right? So when you come to supervised learning problems, we have major classification and regression. And for classification, there are common machine learning algorithms for that. We have the k-nearest neighbors, We have the Bayes classifier, the multi-layer perceptron classifier. And for regression, we have the ARIMA, VAMA and all those things. We have particle filter, least squares, etc. We have the Gaussian process regression. These are regression models. Classification is this belongs here and that belongs there. Regression is trying to find a fit. Look at this. Trying to find a fit, a trend, trying to make future predictions or to fit data. I know that at this time, some of us are getting a little bit confused. I will dwell on this. And when you come to the unsupervised, we have clustering algorithms. Remember, like I said, there is no validity, there is no checking, there's nothing to check where something belongs. It's just like Peter Obi now in his rally. There are 1 million people, right? Gathered in a square. Let me use Opera Square. People full everywhere. And somebody wants to use a drone to capture, okay, how do I know the intellectuals, the middle class, the low class, and the crooks randomly using a drone? There are people everywhere. Probably he will start seeing a cluster of people around the stage. Mostly those are the intellectuals, those people with cap, Labour Party, blah, 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 men with big belly in front. You say, okay, these people are the intellectuals. Middle class can be those, at the middle, at the back. The low class could be those people selling ice cream, selling gala, in a particular section. Then the crooks can be those people hiding under the tree, smoking their stuff. This is a random example. But how can you measure if you're right? How can you? So it is unsupervised, right? So there is nothing to check if you are correct. The only way you can check if you're correct is if each individual says, my name is ABCD, I am a middle class, and you have that class, that label. Mr. A says he's middle class, Mr. B says he's low class, and all those things. You have it, you have the information, so that by the time you classify, you can use it to check how correct you are. But if nobody says where they belong, there's nothing to check it with, right? So there are tasks like that. There's dimensionality reduction. These are different areas. I think it was Victory who asked me something about that, and I told him about this, where you can use PCA and so on and so forth. Then association, right? These are different areas of unsupervised learning, right? And most of the time, these are the two major tasks we perform in unsupervised learning: clustering and dimension reduction. You have the locally linear embedding, you have the PCA, self-organizing maps, LDA, and so on and so forth. There's so many ways of clustering. There's the k-means clustering as well. So, like I said, I'm going to dwell on that. Okay. No. So, who has any questions on this? Any questions?
Yeah.
Okay.
I'm asking from this supervised and classification and regression.
Yeah.
You didn't list all those things. Like, it can be easy for us to, dwell in. Like, those classification, there was an area you listed like and this regression.
Hmm.
Yeah, you
Okay.
didn't list it under like yeah.
Uh, you mean this one here?
Yeah. Like in that classification and yeah, the screen is so I don't know if it's from my phone. No, I don't know. I'm viewing
Ah,
through the phone. I couldn't see the full screen or the rest of it. But I don't
okay.
know.
So let me remind us. There are so many models for different tasks, and this is where people start getting confused. For classification, there are so many classifiers. Support vector machines. We have the Gaussian process classifier. We have convolutional neural networks. We have echo state networks. There are so many. Not all of them are here. But I'm listing these ones here because they are more traditional. There's a lot. If I start listing all of them, it's not even enough. There are even custom models that have been made over time. We can't know them all. But these are standardized traditional models such that if you see them anywhere, you can recognize them. Yeah, that's so. But in general, right? These three are the major tasks that most people do, at least at the beginning stage: classification, regression, and clustering. These are the three things, basically. So, most of your models for recommendation, computer vision, and so on, they are all under either classification, uh, regression, and clustering. So, deep learning. What is deep learning? Like I said, it's when you stack multiple layers of machine learning algorithms. Look at this. We have multiple layers. Look at this: one, two, three, and so on and so forth. Four. The goal is start from the input. In this case, input is an image, right? Or text. You do the processing, and it's a classification model. Is this text a computer science text, or is it a medical science text? And so on and so forth. This is a clear classification task. But for these are machine learning algorithms. This layer is simply a multi-layer perceptron. Multi-layer perceptron. Multi-layer perceptron. But when you stack them up, you have a deep learning algorithm called a deep neural network. See, so let's proceed. So, overall, your task, when you're talking about the difference between machine learning and deep learning, because most of the time, this is what the conversation you start having. Machine learning requires you to have a pre processing step. When I mean pre processing, you have your data, you have to manually design discriminative or correlative features, then put it into your classifier, and then you get output. I'll explain. I want to I want to be able to tell the difference between victory and marvelous. For instance, the difference between them, if I use a feature, if I look at both of them, they are different. But what are those features that are different? If I judge by the hair, their hair is similar. If I look at the hair only, it's similar. So I can't tell who is different. But probably the shape of the nose, the voice, right? These are features. I am crafting out features from them. That is called feature extraction. So, shape of the nose is a feature, the voice, a feature, probably height, feature, intonation, feature. What else? Name, feature, because it's different. My goal is to find features that are different between them. That would help me train a model, a classification model that will be able to give me the outputs. It's Victor or it's marvelous. Now, when you come to deep learning, the difference is that you don't need to find those features by yourself. You just put in the data, the deep learning model automatically finds those features for you and does the classification for you. That's the difference. So most people say that deep learning is easy. It is easy to use, but it's harder to understand and interpret. So if you're an engineer, probably someone who models, like myself, I prefer to use machine learning algorithms because I can interpret it. I can explain what's going on. But in deep learning, it's harder to explain, but it produces better results. And that's why I call it math magic. My area of research now is to discover what is going on in there and interpret them. So, these are the two major differences there. So now we're going into applications, right? So far, if there's any question, feel free to share. Any questions? Okay, let's proceed. So,
Question.
okay, please go on. Hello?
Yeah, let's go. I'm here.
Okay. So, applications, this part is different from the initial not like in business, health, and so on and so forth. This is the application. Like, how do you implement it? I want to apply AI. How? Right? I want to apply deep learning. How? So, in this our series, I'm focusing on deep learning. I know why I'm doing so because that is what's in trend now. It is what's in trend now. Right? But maybe by our next time again, we'll work on traditional models. But for now, let's focus on what's going on. We have a different screen showing, sir. I don't understand. Yeah, I'm seeing it. So the application is number one, the feed-forward neural network. Feed-forward neural network. So what does it do? A feed-forward neural network is simple. If you've studied most of the lectures online, you discover that they keep mentioning things like back propagation, forward propagation, right? Overall, a feed-forward neural network is a kind of network that its learning process is channeled towards a forward, maybe forward ever, backward never kind of mindset. What's going on? So can somebody speak up and tell me what's going on? I don't understand your text.
Maybe it's referring to someone else.
I don't understand too.
Okay. So
Hello. They
yeah.
said they are seeing a screen. So
So
I
what is
get
the
you're not
different
seeing your
screen
screen
you're
because
seeing? I want to know what different means.
I'm seeing no, I'm seeing your full screen, but I think some other people are not seeing the full screen.
Okay, sir. You brought out a slide where they wrote applications of deep learning, and
Okay.
you didn't talk about it. Then you moved forward to feed forward neural networks. That was
Okay.
what I thought.
That is what I'm talking about right now. Like that is like the chapter. So this is chapter 1. Okay.
Okay, sir.
Now it makes sense. So the feed forward neural network is born from the perspective of forward ever, backward never. How can I predict the future? By knowing the present. I want to know tomorrow from today. And most of the time, the networks that enable this are multi-layer perceptrons or vanilla neural networks. Now, I'm trying to segment them so that when you recognize them, you know what this one is for and what this one is not for. So when you're doing a feed-forward neural network, it could be used mostly for regression, for binary classifications, right? And oftentimes, MLPs, multi layer perceptrons, which is these nodes, you can see they are connected, different connections. The forward process from the input to the output is a forward propagation process whereby it tries to learn features, in quote, learn features. And the learning process, to update the process, it goes by a backward propagation to update the weights and minimize the error. Okay. The next one is the deep belief networks. Deep belief networks, they are kind of neural networks. They're obsolete now, very obsolete now, because they were born from clustering algorithms in several layers. You'll be seeing all these things in most texts or discussions. However, it's good that you understand them. Deep belief networks, they are built on clustering RBMs. These are, what's it called again? Restricted Boltzmann machines. To be able to form a stacked layer of networks called deep belief networks. Now they are obsolete. They're obsolete. So why is it obsolete? It is an expensive network. It is trained by a contrastive convergence. It consumes power. That's what I'm saying. And poor performance with newer networks when you compare. And it was popular 10 years ago. Now it's no longer popular. Recurrent neural networks. Now this is the modern for time series forecasting. I want to predict the stock. I want to predict the future. I want to predict the weather. These are the kind of networks for it. Long short-term memory, LSTM, or echo state networks. You also have GRUs, gated recurrent units. All those English. Don't try to cram them. It is just for you to understand the concept, how it works. It is these networks recurrent. That is, you go forward 2 steps, you go back once to try to understand your progress. Most of the time, when people make predictions, their minds work based on the concept of recurrent neural networks. Okay. And another popular one that is used mostly for computer vision is the convolutional neural network. So this one mimics the visual network of the human brain. What can this network see? Like, how can the computer see? That is why it's used for computer vision. That's why it's called computer vision. So most computer vision networks or architectures are built based on convolutional neural networks. How does it work? It scans an input, which is an image, and it extracts different discriminative features, feature maps, as you can see here, using a scanning technique. You know how the robot, if you watch these movies, when they want to assess something, it will scan it. That is what it does on an image or a video, right? So overall, it's built on, you have the input layer, you have the convolutional neural layer, the pooling layer, and the fully connected layer. I wouldn't be going deep into this today. Today is about introducing you to it and knowing what it does. Then, how can you implement these things? What are the resources available out there for you? We have Keras, built on TensorFlow, and we have the scikit-learn, we have Theano, we have PyTorch. These are different machine learning and deep learning libraries available for use in Python. Most people find TensorFlow easier. Actually, I was using TensorFlow in Korea. I got here. What they use here is PyTorch. So I'm learning PyTorch while also, doing, of course, whatever you do in this, you can do in that. I started with scikit-learn. It's the introductory for, basic machine learning algorithms, support vector machines and all that. Migrated into Keras, TensorFlow. Now I'm in PyTorch. So these are the resources out there. Now, limitations. Let's talk about this real quick. I don't think we have enough time left. Connecting the dots. Overall, the problem is, how can I classify? How can I cluster? How can I fit a curve? And how can I make predictions? These are the major problems, no matter the area of study. How can I make classifications, cluster, fit, or predict? These are the goals overall. However, how can you do that? How can you trust that prediction? What is going on? Right? These are questions. So in order to better understand, there are problems. One is those algorithms. How can you optimize them? How can you trust them? How can you interpret them? Because whatever is going on in the background relies on mathematics, on assumptions, very expensive assumptions. So how can you be able to reduce the assumption, or how can you improve speed, and how do you reduce memory? The learning process itself, what we know is the gradient descent most of the time. It says here, it has low memory and low speed. You see, so if you want more speed and you want to pick a learning method, understand that it's going to require more memory. So these are limitations that, that are in place. So these ones are the unpopular methods. Most people know about gradient descent. It's popular, but it's slow. See, now it's slow and it consumes less memory. So I think we have 5 more minutes. So what do we guys think? Should we stop here? Maybe take questions? Or should we maybe take questions and come back again. What do we think? So okay, if anybody has a question, please feel free.
Okay. Good evening, sir. Thank you for your class.
Yeah.
I suggest we come back before we take question because this 4 minutes will not be enough to answer our question, sir.
Yeah, I think so as well. So what I'm gonna do now is I'm gonna create another meeting, right? New meeting. Let me do this. Create instance meeting, and I'll drop the link in the group. So as soon as you see the link, join it. Let's go. Okay. So I'm gonna create the link, and okay, I just created it. Boom. Boom. All right. Without further ado, um, so once you see the link, join in. Let's end this, right?
Yes,
Okay.
better.
All right. I'll see you guys soon.